So hello students, welcome to one more session of computer networking and security. In this session we will see Diffie Hellman key exchange. So in the previous session we have studied private key encryption technique and public key encryption technique. In public related algorithm to private key encryption techniques are DES, then AES, data encryption standard, and advanced encryption standard. And for this one, public key encryption technique is RSA. We studied all those algorithms. So in the last session we have seen the problem related to RSA. So now one of the major problem with the symmetric key encryption technique. Symmetric key encryption technique is the one in which both sender and receiver they share same key. Both sender and receiver they share same key. Now the question comes, how the sender and receiver will share the same key, or how the sender and receiver will agree upon the same secret key, because it is not the question like sender and receiver they are sitting beside to each other and communicating with each other. This is the problem that the sender is at the one corner of the world and the receiver may be in the other corner of the world. Both are communicating with each other without seeing each other. So that is the problem here, how the sender and receiver will share the secret key. Is it possible to share the key through other alternative ways such as reliable courier or postal service? No, in this internet age that is not possible. So one alternative to this one is RSA. The sender and receiver they can use RSA, public key encryption technique, and they can share the key. Other technique is called as Diffie Hellman key exchange technique. The other technique is called as Diffie Hellman key exchange technique to share the key based on some mathematical calculation. So by doing some mathematical calculation, both sender and receiver will come to will share the key by this method. So before starting this one, students please note this algorithm is not for encryption or decryption technique. This algorithm Diffie Hellman is only to used for key exchange technique. It is only to key exchange technique. It is not used for encryption or decryption. So you have to note this one. Now it is proposed in 1976. Allows group of users to agree on secret key over an insecure channel, cannot be used for encrypt and decrypt message, depends on its effectiveness on the difficulty of computing discrete logarithmic problem, because the technique is somewhat robust to certain extent. Here hacker will not be able to compute the key because this problem is called as a discrete logarithmic problem. Now here you will see the algorithm. A and B wants to agree on secret key. A and B want to agree on secret key. So they agree. First A and B agree on two large numbers n and g, such that g lies between 1 and n. Now A chooses a random x. This is the lowercase x I am using here. A chooses random number x and computes x is equal to g raised to power x mod n. So here you see both A and B agree on two large numbers n and g. So now n and g is known to each other. Both A and B. Now after that, A chooses random number x and compute x g raised to power x mod n, and A will send x to B. Similarly, B chooses a random number y, computes y is equal to g raised to power y mod n and sends y to A. Now A computes y, whatever this one, the value received from B, that is y, raised to the power x. This is because A chooses the random number x mod n and B computes x raised to power y mod n. A computes y raised to power x mod n. Let us call that is a k1, and B computes k2, nothing but x raised to power y mod n. Now you see here, you see this one here, x computes k1 is nothing but y raised to power x mod n. Then what is x here? y raised to power x mod n, and B computes k2 is nothing but x raised to power y mod n. Now what is y here? Y is nothing but gy mod n. So y is nothing but gy x, that is lowercase x mod n, that is nothing but you will get here g raised to power xy mod n. Similarly here x is nothing but g raised to power x y mod n, that is nothing but g raised to power xy mod n. So here you see, ultimately at the end both k1 and k2 are the same. Now k and k2 are same, that means both have, that is A and B, they have now the same secret key, and now they can continue with the secret key encryption technique. Now they can continue with secret key encryption technique, because we know secret key encryption technique is faster compared to asymmetric key encryption technique. So asymmetric key encryption technique makes use of two keys, that is private and public. Secret key encryption techniques makes use of single key, but the sharing of the single key is a bit difficult. That's why both A and B, they share the single key by means of this calculation. And here now the question comes, even if the hacker or attacker is in between the channel, and if he gets the information here G N, still it is found that it is not possible to find out K1 and K2, because this is called as logarithmic complex problem. It is found that according to the cryptanalysis, this is found that this is logarithmic complex problem. So in this way both will share the key. Now you see here, this is the flow. Here both user A and user B is there. User A choose X, and both first they will choose G and N, right? That we know. Now user A calculate capital X by raising G raised to power X mod n. Similarly, and you will send that to Y. Similarly, B will calculate capital Y is equal to G raised to power Y mod n. Now after that both will compute, that is A will compute Y raised to power X mod n, and B will compute X raised to power Y mod n. Both are same, then finally both found to be same. So these are the statements from the exam point of view. Transmitter and receiver create a secret shared key by using service of exchange over the public network. Transmitter and receiver agreed on the use of large prime number, see here, that is P, of about 1000 bits long, and A generated number is G less than P, and a generated number less than P. Then transmitter picks random number X and calculates this one. Similarly, receiver calculates this one. Both transmitter receiver exchange, and finally they will come to one conclusion of the shared key. So this is the now the next concept is digital signature. You know, digital signature, or the other name that is called as authentication. Authentication is very important. When A wants to send the message to B, B should know that B should be able to verify that the message is sent by A only. A is the authenticated person. So here the secrecy of message is not important here actually, but authentication is important. Now here the first point you will see, a handwritten signature is a function of the signer only, not the message. Handwritten signature can be copied and posted. So now the digital equivalent of the handwritten signature would be useless in e-commerce. Digital equivalent of the handwritten signature would be useless in e-commerce applications. So what is required actually? Must be able to compare with the real signature and must be sure it is not copied or posted. How A can prove its identity over the internet? Now the question comes, how A or the sender can prove its identity over the internet? So a digital signature is a function of both signer and the message. So please remember here, a digital signature is a function of both signer and the message. Digital signature is a digest of the message encrypted with the signer's private key. So very important. So in the when I explaining public key encryption techniques and the application of the public key encryption techniques, so I have explained what is authentication. In the authentication, so sender will send the message by encrypting the message with this private key, and he will send that message to the receiver, and receiver will decrypt with the sender's public key, because receiver has got sender's public key. He will decrypt the message with the sender's public key. A digital signature is the digest of the message encrypted with the signer's private key. So here authentication is important, not the secrecy of the message, but authentication is important. So how it works, digital signature? Digital signature works like message M. So by using certain hash algorithm, the hash function or hash algorithm, hash value of the message is find out. So you have to find out the hash value of the message, or hash value of the message is calculated by using a hash algorithm, that is also called as message digest. By using hash algorithm, SHA, it will calculate the hash value of the message. Once the hash value of the message is there, after that here sender will use his private key, encrypt the message. He will append the hash value to the message, and he will encrypt that message and hash value with the private key of sender, and encrypt the message with the hash value and message with the hash value, encrypt with the private key of the sender, and he will send it that to the receiver. On the this is called as a digital signature. This is called as a digital signature. So you have to remember here, digital signature makes use of the private key of the sender. So here it is not just encrypting the message with the private key. Here the sender first will use the hash algorithm and calculate the hash value, and he will append that hash value to the message, and after appending the hash value to the message, he will encrypt that message and hash value with the private key of the sender, and this is known as the digital signature. This is known as the digital signature. Now you see how it works exactly. So this is the original documentation. Original documentation is subjected to the hash function. Now this hash function will give some hash value. Now this hash value and the message is encrypted with the sender private key, and that is known as a digital signature. So original documentation and digital signature. Finally receiver gets original documentation and the digital signature. So hash value is encrypted with the private key, that is the digital signature, and finally original documentation and digital signature receiver gets. So you see the computation. Digital signature is computed by applying one-way hash function to the original document, encrypting the result with the sender's private key. How the receiver can verify? Receiver can verify this one by applying one-way hash function to the received document. So what receiver will do? Receiver will apply one-way hash function to the received document, decrypt the signature using sender's public key, and will compare the two results that means equality of means of document unmodified. He will compare it for whether the document is unmodified or not, something like that. Because what the receiver is doing here, original documentation is document is there. For original document, he will compute the hash function. Now you will check the hash function with the received hash function, like this digital signature. If both are matching, means the original document is not modified in between. That is the thing. Now we have one more concept here, that is called as a digital certificate. So digital certificate, a digital identity document binding public and private key pair to a specific person or organization is called as a digital certificate. Verifying digital signature only proves that the signer had the private key corresponding to the public key used to decrypt the signature. Does not prove that public private key pair belong to the claimed individual. For that we need a digital certificate. The third party will provide digital certificate. So the main content of the digital certificates are a serial number, name of the holder, public key of the holder, name of the trusted third party, their certificate, digital signature of the certificate authority, data on which hash and public key algorithm have been used. All those things are contained in the digital certificate. Now we will move to your class notes. Student, in your syllabus, the topic is authentication. So authentication is achieved by means of digital certificate and digital signature, right? So I have already explained that one. Now we will see what is that exactly. Message authentication verifies the authenticity of the both message and this message sender and the message content. Message sender is authenticated through implementation of a digital signature. So message content is authenticated through implementation of a hash function and encryption of the resulting message digest. Hash function is used to produce the fingerprint of the message. Hash value is added at the end of the message before transmission. So now we will see here in this diagram. Here you see user is there. What you will do is you will take the message. He will apply the hash function to the message, and you will calculate the hash value, or what you call like message digest, or what you call one more name, that is here it's given here, message digest or fingerprint of the message. Once we calculate the fingerprint of the message, then next one is the message is encrypted with the private key of the sender. Message is encrypted with the private key of the sender. Here you can see message with the hash value, and it is sent to the other end. On the other end, what the receiver will do, will extract that hash value, and he will use the public key, and he will compute the like he will decrypt that one. He will get the hash value, and he will take the message part. And message part, he will once again he will calculate the hash function, and he will compare both one. If both hash values are matching, means the message is unmodified. Message is unmodified. So second session also you will see the same thing here. So message is unmodified. So this is the technique used in digital signature. So students, you can see here, like digital signature, this slide shows the digital signature process. So message, so what we are doing here, message, with the message you will apply the hash function and you will calculate the hash value. Then hash value is encrypted with the sender's private key. Then that is called encrypted message digest. And the message is appended with this one, encrypted message digest. Message is appended to the encrypted message digest. So on the other end, what the receiver will do is, you will take the message, you will compute the hash value, you will take the encrypted digest, and by using the public key of the sender, he will decrypt it. Actually, this is called a digital signature, and he will compare the, he will compute the hash function of the original message, and he has got also the hash function, hash value of the this one, hash value he got through the encryption process. He will compare the both. If the both are same, then there is no modification of the message. So that's the one thing you have to understand here. The next topic is here is, so hash function for to obtain the hash value, you will use the different algorithms are used here. The algorithms are MD5 hash function, widely used algorithm, and one more algorithm is called as SHA1 is also used. Now the last concept in this session is the firewall. We know what is the use of the firewall. Firewall isolates the organization's internal network from the larger internet, allowing some packet to pass, blocking the others. Here you can see every organization has got a firewall, so that it will isolate the intranet from the internet of the organization. Here you can see this is the like intranet session of the organization. This is the internet. So in between firewall is there. So what it will do is it will provide the isolation, or it will secure the packet moving from the input side to output side, and output to the input side of the network. So why firewalls are required? The main purpose of the firewall is like it will prevent denial of service attacks. In the previous session, I explained what is the DOS or DDoS, distributed denial of service attack. The other name for this attack is also called as a sink flooding. Attacker, what they will do, they will establish many bogus TCP connection, so that by doing that one, they will make the no resource left for the real connection. I explained this one, how the hacker can bombard like a particular website by sending unnecessary junk packet. So second one is prevent illegal modification or access of the internal data. This is the second use of firewall. Third one is allow only unauthorized user to access the inside network. So this is the main use of the firewall. Three types of firewalls are there. One is called as stateless packet filters, stateful packet filters, and application gateway. Now, stateless packet filtering. So here you can see internal network connected to the internet via firewall. But here firewall filters the filters by adopting packet by packet. Like it will check source IP address, so destination IP address. So particular source IP address to particular destination IP address is allowed or blocked. Or blocking is based on TCP and UDP port numbers. Blocking is based on ICMP message type. Blocking is based on TCP and sync and acknowledgement bit. So stateless packet filtering. Example here, you can see the example: block incoming and outgoing datagrams with IP protocol field is equal to 17, and with either source or destination 23. You know what is 23? 23 is the telnet. So it will block all the UDP packets and telnet connections are blocked here. You see, this is the thing. Next one is block inbound TCP segments with acknowledgement 0. Prevents external clients from making TCP connection with the internal clients, but allows internal clients to connect to the outside. So now stateless packet filtering policies and settings are something like that. So no outside web access, drop all the outgoing packet to any IP address port number 80. No incoming TCP connection except those for the institution's public web server. Drop all incoming TCP packet except from this port. Prevent web radios from eating up the available bandwidth. Drop all incoming UDP packets except DNS. Like this it works. Different policies you can see here. So here you can see in the firewall mainly works based on the access control rule or access control table, ACL. ACL is a table or a table of rules applied from the top to bottom of incoming packet. Here you can see in the ACL, first they allow like particular packet, allow source, destination based on the TCP or UDP based on the port number. Finally at the end deny all. So it will deny all the packet. First it will allow group so based on the requirement it will allow particular packets, finally deny. Suppose if you put deny statement at the beginning, then it will deny all the packet and it will not allow any other packet. So deny statement should be at the end. so that it can allow these packets based on the rules and conditions, then deny all the packet. Similarly, you can see here stateful packet filtering. Stateless packet filtering is something like it is heavy-handed tool, like it admits packet that makes no sense. Example, destination port 80, acknowledgement bit set even though no TCP connection is established. That's a disadvantage. But in the case of stateful packet filtering, it will track entire connection, like whether the setup has been done or not, like sync connection is there or not, pin connection is there or not, like that. So stateful packet filtering, here it's given. Here you can see even though firewall some of the settings are there, like rule settings are there, but here after checking stateful packet filtering, it will deny some of the connection you see here. So application gateway filter packet on the application data as well as TCP, IP, UDP fields. So application gateway sometimes they will call as a proxy server. So example, allow selected internal user to telnet, require all telnet user to telnet through the gateway. So for authorized user, gateway sets up telnet connection to the destination host. So in this way it works.